TrustSec is a next-generation access control method that can greatly enhance the performance, scalability, and manageability of your network. TrustSec implements a central policy implemented as a matrix comprised of three main functions: classification, propagation, and enforcement. Classification is enabled by Cisco Identity Services Engine Context Awareness, the who, what, how, where, and when particulars of a given user session. Server connections can be statically classified based on expected usage and your security needs. This classification knowledge then propagates throughout your infrastructure. When endpoint frames arrive at their Ingress Network Access Device, or NAD, the NAD inserts a special tag into the Layer 2 header. These scalable group tags, or SGTs, are also referred to as simply tags, on which forwarding, filtering, or inspection decisions are based. The system is now capable of enforcement. TrustSec-capable downstream devices can permit or deny access based on these tags by using a new type of access control list, or ACL, implemented on switches as a security group ACL or SG-ACL, and on firewalls as an SG firewall. Let's dive in. With NDAC, network devices in a TrustSec cloud are verified by a peer device using 802.1x with EAP-Fast. Now, this allows for IEEE 802.1ae encryption between devices, so you're secure. EAC is the formal name for endpoints connecting to NADs. Successful authentication and authorization results in SGT assignment. EAC access methods include 802.1x, MAB, and WebAuth. A security group is a group of users, endpoint devices, and resources that share access control policies. You, the administrator, define scalable groups in Cisco ISE. Now, the security group tag, that's a unique 16-bit scalable group number assigned to each security group. You do not have to manually configure scalable group numbers. They automatically generate in a sequential manner. However, you can also reserve a range of SGTs for IP to SGT mapping. Now, these tags are applied as frames enter a trusted network and are untagged as they egress a trusted network. Now, speaking of tags, here's the additional Layer 2 headers that you can add for TrustSec deployments. The Cisco TrustSec solution supports hop-by-hop encryption and integrity authentication based on the IEEE 802.1ae standard. Now, this is not directly related to tagging, but it's shown here to more fully depict the TrustSec solution. You can also see the Cisco metadata header, or CMD header, which includes several fields. Now, the most important for this discussion is the actual tag, that SGT value, which is added at the Ingress port of SGT-capable devices. The CMD header is added before other Layer 2 services, such as QoS. The 802.1ae and Cisco metadata headers have minimal impact on frame size. Together, they only add about 40 bytes to the frame size, less than a baby giant frame. Here's a TrustSec deployment scenario. An administrator created a centralized policy matrix on Cisco ISE. Now, this policy is automatically downloaded to NADs in the form of SG-ACLs, which control access based on SGTs. This simplifies security policy management. Additionally, TrustSec network devices obtain data from Cisco ISE after they form a secure connection to Cisco ISE. It's called pack provisioning. So this information includes a list of radius servers they can use for authentication, the security group to which they belong, and an expiry timeout to control data refresh rate. Security Exchange Protocol, or XSP, propagates the IP to SGT binding table across network devices that are not SGT capable. SGT reservation enables you to reserve a range of SGTs for IP to SGT mapping. Now, this IP to SGT mapping binds an endpoint IP to an SGT and provisions it to a TrustSec capable device. Now, this is usually to map SGT to destination servers. Identity to port mapping is a method for a switch to define the identity of a port to which an endpoint is connected. It uses this mapping to look up a particular SGT value in Cisco ISE. Okay, so take a moment to notice how non-compliant devices will be tagged, employee devices will be tagged, and suppliers will be tagged. Remember, this is tagged as they enter the network access device. Network access devices will only allow sources to reach appropriate destinations based on the Cisco ICE central policy. Now, you can pause the presentation for a moment if you like and analyze the central policy as it relates to this example. Okay, meanwhile, one of the greatest advantages of TrustSec is that it is topology independent. IP addressing is not relevant to this solution. This independence can improve network performance and scalability and can greatly ease security administration. So let's take a look at how traditional ACLs play out. Suppose we have a range of source IP addresses. We'll call them S1 to S4 and a range of destination addresses D1 through D6. So any S1 source address must be able to access any D1 destination address in this scenario. Now, 4 permissions are required. They must be able to use HTTPS, port 8081, and port 445. All other traffic to these destinations should be denied. So, to ensure that the S1 sources can access all 6 destination ranges, with the 4 permissions, will require you to create 24 access control entries, or ACEs, in your access control list. Now, let's suppose that each of the 4 source ranges, S2, 3, and 4, require similar access. You would have to create a total of 96 ACEs in your ACL. Now, these things tend to grow over time. Imagine if you had 400 sources times 300 destinations with the same 4 ACEs. That's 48,000 entries in an ACL. Now, how could this be handled with TrustSec? Well, you merely define your 4 source groups with, say, SGT 10, 20, 30, and 40, and your 3 destination server groups with SGT 400, 500, 600 in this example. So that's 4 sources times 3 destinations times the same 4 permissions. That's only 12 ACEs. Furthermore, instead of large ACLs being individually managed on each network device, you have small SG ACLs that are centrally managed on Cisco ICE.